Na, 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 na. Muy buenas, damas y caballeros. Tenemos aquí la bebida. Lo tenemos todo preparado. Vamos a empezar el día viendo la GTC de Nvidia. Así es. GTC de Nvidia. A ver si se nos pone. Aquí está. ¿Vale? Quito así, más o menos. Vale. Sí, ¿no? Así se ve bien, más o menos. Lo hacemos grande. Espera, antes de nada, subtítulos. Subtítulos, inglés y español, ya está puesto. Y vamos allá. A ver qué nuevas nos trae Nvidia. ¿No? Va a estar ahí, algún día estaremos ahí, ¿eh? Os haré un blogazo de esos. En directo. Elegante y bonito. Es buen show. Para verla así de mañana.
I am a visionary.
Oh.
Illuminating galaxies to witness the birth of stars. And sharpening our understanding of extreme weather events. I am a helper, guiding the blind through a crowded world.
I was thinking about running to the store.
And giving voice to those who cannot speak.
Do not make me laugh.
I am a transformer,
Dios. Qué guapo.
harnessing gravity to store renewable power. And paving the way towards unlimited clean energy for us all. I am a trainer, teaching robots to assist, to watch out for danger,
El futuro viene. Señores. El futuro se
help
acerca.
save lives.
Ah, coño, es verdad. Perdonad,
I am a healer,
Ay.
providing
sí,
a new
así veis.
generation of cures and new levels of patient care.
Doctor, that I am allergic to penicillin. Is it still okay to take the medications?
Definitely. These antibiotics don't contain penicillin, so it's perfectly
Sí,
safe for
vamos
you
a
to take.
deshacernos de todos los trabajos. ¿Para qué un doctor?
Navigator,
Bueno, a ver, el doctor va a su persona y tal, pero a lo lejos
generating
sí.
virtual scenarios to let us safely explore the real world and understand every decision. I even helped write the script. Breathe life into the words en muchos idiomas. Y escribí la música.
O sea, qué bonito.
I am AI,
Así es.
brought to life by Nvidia, deep learning, and brilliant minds everywhere.
Please welcome to the stage NVIDIA founder and CEO Jensen Huang.
Vamos allá. A ver qué nuevas nos traes. Una de las mejores gráficas que hay.
Welcome to GTC.
I hope you realize this is not a concert. You have arrived at a developers conference. There will be a lot of science described, algorithms, computer architecture, mathematics. I sensed a very heavy weight in the room all of a sudden. Almost like you were in the wrong place. No conference in the world is there a greater assembly of researchers from such diverse fields of science.
Yes.
From climate tech to radio sciences trying to figure out how to use AI to robotically control MIMOs for next generation 6G radios, robotics, self-driving cars, even artificial intelligence. Even artificial intelligence. Everybody's...
Hay que usarlo todo. Tenemos
I
que
noticed a
evolucionar
sense of
y
relief
crecer.
there all of a sudden. Also, this conference is represented by some amazing companies. This list, this is not the attendees. These are the presenters. And what's amazing is this. If you take away all of my friends, close friends, Michael Dell is sitting right there, in the IT industry.
BMW también.
All of the
BMW.
friends I grew up with in the industry. If you take away that list, this is what's amazing. These are the presenters of the non-IT industries using accelerated computing to solve problems that normal computers can't. It's represented in life sciences, healthcare, genomics, transportation, of course, retail, logistics, manufacturing, industrial. The gamut of industries represented is truly amazing. And you're not here to attend only, you're here to present, to talk about your research. $100 trillion of the world's industries is represented in this room today. This is absolutely amazing.
Vamos a verla.
There is absolutely something happening. There is something going on. The industry is being transformed, not just ours. Because the computer industry, the computer is the single most important instrument of society today. Fundamental transformations in computing affects every industry.
Así es.
But how did we start? How did we get here? I made a little cartoon for you. Literally, I drew this. In one page, this is Nvidia's journey. Started in 1993. This might be the rest of the talk.
OpenAI 2022, aprendes.
1993, this is our journey. We were founded in 1993. There are several important events that happened along the way.
Prompt engineering,
I'll just highlight a few.
startups,
In 2006,
nueva revolución
CUDA,
industrial.
which has turned out to have been a revolutionary computing model, we thought it was revolutionary then.
Así
It
es.
was going to be an overnight success, and almost 20 years later it happened.
Lo que se viene, ¿eh?
We saw it coming
Lo que se
2
viene.
decades later. In 2012, AlexNet, AI, and CUDA made first contact. In 2016, recognizing the importance of this computing model, we invented a brand new type of computer. We called it DGX-1. 170 teraflops in this supercomputer.
Oh,
8
damn.
GPUs connected together for the very first time. I hand-delivered the very first DGX-1 to a startup located in San Francisco called OpenAI.
Primer modelo de OpenAI fue en 2016.
DGX-1 was the world's first AI supercomputer. Remember, 170 teraflops.
Joder.
2017, the transformer arrived. 2022, ChatGPT capture the world's imaginations, have people realize the importance and the capabilities of artificial intelligence. In 2023, generative AI emerged and a new industry begins. Why? Why is a new industry? Because the software never existed before.
Así es.
We are now producing software, using computers to write software, producing software that never existed before. It is a brand new category. It took share from nothing. It's a brand new category. And the way you produce this software is unlike anything we've ever done before. In data centers, generating tokens, producing floating point numbers at very large scale. As if in the beginning of this last industrial
Básicamente eso es como
revolution,
decir que le
when
está
people
metiendo
realized
información
that
a la
they would
IA,
set up factories,
reconociendo
apply
patrones,
energy to it,
aplicando un
and this invisible, valuable thing called electricity came out.
complicado de
AC
explicar,
generators.
pero está muy guapo,
And
está
100
muy
years
guapo.
later, 200 years later, we are now creating new types of electrons, tokens, using infrastructure we call factories, AI factories, to generate this new, incredibly valuable thing.
Va a
called
salir
artificial
algo potente
intelligence.
en
A
poco
new
tiempo,
industry has emerged.
Madre mía.
Well, we're going to talk about many things about this new industry. We're going to talk about how we're going to do computing next. We're going to talk about the type of software that you build because of this new industry, the new software, how you would think about this new software. What about applications in this new industry? And then maybe what's next? And how can we start preparing today for what is about to come next?
Así es.
Well, but before I start, I want to show you the soul of Nvidia,
A ver,
the soul of our company. At the intersection of computer graphics, physics, and artificial intelligence, all intersecting inside a computer in Omniverse, in a virtual world simulation. Everything we're going to show you today, literally everything we're going to show you today, is a simulation, not animation. It's only beautiful because it's physics. The world is beautiful. It's only amazing because it's being animated with robotics. It's being animated with artificial intelligence. What you're about to see all day is completely generated, completely simulated in Omniverse, and all of it, what you're about to enjoy is the world's first concert where everything is homemade.
¡Qué guapo, tío! ¡Sí, señor! ¡Madre mía!
Everything is homemade. You're about to watch some home videos. So sit back and enjoy yourself.
A tu salud. Todo casero. Todo por IA. Natomiast ten 3D zdejmie, Autodesk Maya. Buah, los juegos con IA. Escuchadme, los juegos con IA inteligente, que aprenden a vencerte, que aprenden a todo. Es que vamos a alucinar con los juegos que se vienen y con todo en general. Un juego en donde es de supervivencia y te enfrentas a enemigos, ¿no? Los enemigos pueden construir, los enemigos aprenden a luchar, aprenden a cazarte, tú tienes que aprender a cazarlos. Los NPCs, todo va a cambiar, una puta evolución. Un juego que no tiene historia creada y tú vas charlando con los NPCs y vas creando la historia en el camino, con una IA hecha y programada, solo teniendo el enfoque de hacer que te lo pases bien en el juego, de hacer una historia para ti. En el futuro puede llegar una maldita IA, ¿vale? De un juego en el que tú entras en el mundo, te creas el personaje, la IA habla contigo, te conoce, ve lo que te mola y te va creando el juego con los materiales que tiene, con la codificación que tiene ya preparada metida en el prompt, para que se adapte a ti. El juego perfecto, donde tú lo disfrutas, donde todo es nuevo, donde ya no hay patrones, todo es... Es que es impresionante. Eso en el mundo de los juegos. Solo en el mundo de los juegos. Hablar con un personaje, decirle cosas, que te conteste, pulsar el botón, hablarle, que te oigan, es una maravilla. Es una maravilla. No tenéis ni idea, o sea, es... Madre mía lo que se viene. Uf, y los gráficos, madre mía del señor. Oh. Los están entrenando. Madre mía, los diseñadores, ¿cómo van a diseñar cosas con esto? Vale, vamos a hacerlo. Luego ya lo que más se va a valorar en el futuro será nuestra creatividad. ¿Vale? El futuro es bueno en general para todos los trabajos. Yo espero que algún día llegue una mejora tecnológica tan fuerte que, yo que sé, hagas un trabajo durante 3 4 horas al día y el otro tiempo pues lo dediques a mejorar, ¿no? Por así decirlo. Porque ya todo el trabajo en general se va a complementar con esto, con la IA. Y ya nos podemos centrar en lo que hay en el mar, en lo que hay fuera. Oh, muchas expectativas te genera esto, ¿eh? Pero bueno. Bien, bien, bien. Más IA. IA simulación de ciudad de persona. Simulación de caída. Muchas pruebas. Detección de coches. Control de peatones, control de señales. Bien, 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 bien. Puede fallar. Pero puede fallar. O sea, necesita una perfección bastante fuerte. Imagínate que, bueno, ahora están practicando, según tengo lo último de vehículos de los coches, que están practicando que detecten también cuando señalizan, ¿no? Oye, este se mete en la rotonda, señaliza hacia la derecha para salir, lo que sea. Y hay veces que no ha detectado en la simulación que he visto yo en otro momento. Tengo que ver estas cosas más en directo con vosotros, ¿eh? Porque es brutal, o sea, todas las mejoras y todos los avances me dan una inspiración. Y todo esto ha sido generado con ella, todo ese videíto. Es impresionante el futuro.
God, I love Nvidia.
Sí, sí, ya veré, ya me gustaría a mí correr ahí.
Accelerated computing
Podría tirar un currículum,
has
quién
reached
sabe,
the
¿eh?
tipping point. General purpose computing has run out of steam. We need another way of doing computing so that we can continue to scale, so that we can continue to drive down the cost of computing, so that we can continue
Podemos usar la IA, mejorar la
to
IA en todo.
consume more and more computing while being sustainable. Accelerated computing is a dramatic speed up over general purpose computing. And in every single industry we engage, and I'll show you many, the impact is dramatic. But in no industry is it more important than our own.
No, no, si
Industry
trabajos va a
of using
haber.
simulation tools.
La gente que dice que no habrá trabajos, yo estoy seguro de que habrá trabajo.
In this industry,
Siempre hay una
it's not
forma.
about driving down
Siempre
the
la
cost
encontramos.
of
Cada vez
computing.
que hay
It's
un
about driving
cambio,
up the scale of computing.
siempre que hay un
We would
cambio,
like to be able to simulate
lo
the
conseguimos.
entire product that
Somos
we do
seres
completely
humanos.
in full fidelity, completely
avanzamos.
digitally, in essentially what we call digital twins. We would like to design it, build it, simulate it, operate it completely digitally. In order to do that, we need to accelerate an entire industry.
Ok.
And today, I would like to announce that we have some partners who are joining us in this journey to accelerate their entire ecosystem so that we can bring the world into accelerated computing. But there's a bonus. When you become accelerated, your infrastructure is CUDA GPUs. And when that happens, it's exactly the same infrastructure for generative AI. And so I'm just delighted to announce several very important partnerships. They're some of the most important companies in the world. Ansys does engineering simulation for what the world makes. We're partnering with them to CUDA accelerate the Ansys ecosystem, to connect Ansys to the Omniverse digital twin. Incredible. The thing that's really great is that the installed base of NVIDIA GPU accelerated systems are all over the world, in every cloud, in every system, all over enterprises. And so the applications they accelerate will have a giant installed base to go serve. End users will have amazing applications, and of course, system makers and CSPs will have great customer demand. Synopsys. Synopsys is NVIDIA's literally first software partner. They were there in the very first day of our company. Synopsys revolutionized the chip industry with high-level design. We are going to CUDA accelerate
Manda un
Synopsys.
mensaje a los
We're
padres que voy a hacer
accelerating
que lo vean también
computational
el vídeo este.
lithography, one of the most important applications that nobody's ever known about.
Vale, a
In
ver.
order to make chips, we have to push lithography to the limit. NVIDIA has created a library, a domain-specific library, that accelerates computational lithography incredibly. Once we can accelerate and software define all of TSMC, who is announcing today that they're going to go into production with NVIDIA cuLitho. Once it's software defined and accelerated, the next step is to apply generative AI to the future of semiconductor manufacturing, pushing geometry even further.
Ok.
Cadence builds the world's essential EDA and SDA tools. We also use Cadence. Between these three companies, Ansys, Synopsys, and Cadence, we basically build NVIDIA. Together, we are CUDA accelerating Cadence. They're also building a supercomputer out of NVIDIA GPUs so that their customers could do fluid dynamic simulation at 1,000 times scale. Basically, a wind tunnel in real time. Cadence Millennium, a supercomputer with NVIDIA GPUs inside. A software company building supercomputers. I love seeing that.
A mí
Building
también, me
Cadence
encanta.
co-pilots together. Imagine a day when Cadence could, Synopsys, Ansys, tool providers would offer you AI co-pilots so that we have thousands and thousands of co-pilot assistants helping us design chips, design systems. And we're
Wow.
also going to connect Cadence Digital Twin Platform to Omniverse. As you can see the trend here, we're accelerating the world's CAE, EDA, and SDA so that we could create our future in digital twins. And we're going to connect them all to Omniverse, the fundamental operating system for future digital twins.
Impresionante.
One of the industries that benefited tremendously from scale, and you all know this one very well, large
GPT-1,
language models.
GPT-2, GPT-3.
Basically, after the transformer was invented, we were able to scale large language models at incredible rates, effectively
Este
doubling
que
every
veis
6
aquí de
months.
aquí arriba es el
Now, how is it
GPT-4.
possible that by doubling every 6 months, that we have grown the industry, we have grown the computational requirements so far? And the reason for that is quite simply this. If you double the size of the model, you double the size of your brain, you need twice as much information to go fill it. And so every time you double your parameter count, you also have to appropriately increase your training token count. The combination of those two numbers becomes the computation scale you have to support. The latest, the state-of-the-art OpenAI model is approximately 1.8 trillion parameters.
Me cago en todo,
1.8
tío.
trillion
Es que es
parameters
demasiado. ¿Qué,
required several trillion tokens to go train.
qué
So,
persona?
a few trillion parameters on the order of, a
No
few
podemos hacer
trillion
eso
tokens on
como
the order
seres
of, when you
humanos, o
multiply
sea,
the two of them together,
la IA nos
approximately
complementará.
30, 40, 50 billion, quadrillion floating point operations per second. Now we just have to do some CO math right now, just hang with me. So you have 30 billion quadrillion. A quadrillion is like a peta. And so if you had a petaflop GPU, you would need 30 billion seconds to go compute, to go train that model. 30 billion seconds is approximately 1,000 years. Well, 1,000 years, it's worth it.
Sí,
I'd like to do it sooner, but it's worth it. Which is usually my answer when most people tell me, hey, how long is it going to take to do something? So 20 years? It's worth it. But can we do it next week? And so 1,000 years, 1,000 years. So what we need are bigger GPUs.
así es.
We need much, much bigger GPUs. We recognized this early on, and we realized that the answer is to put a whole bunch of GPUs together. And of course, innovate a whole bunch of things along the way, like
Eso
inventing
es
tensor
verdad. ¿Qué
cores,
cojones? Si no tienes una GPU
advancing
grande,
NVLink
unas
so that we could create
juntas.
essentially virtually giant GPUs, and connecting them all together
que
with
mirad-
amazing networks
mirad la
from a company called
cantidad
Mellanox,
de
InfiniBand,
GPUs.
so that we could create these giant systems. And so DGX1 was our first version, but it wasn't the last. We built supercomputers all along the way. In 2021, we had Selene, 4,500 GPUs or so. And then in 2023, we built one of the largest AI supercomputers in the world. It's just come online, EOS. And as we're building these things, we're trying to help the world build these things. And in order to help the world build these things, we got to build them first. We build the chips, the systems, the networking, all of the software necessary to do this. You should see these systems. Imagine writing a piece of software that runs across the entire system, distributing the computation across thousands of GPUs, but inside are thousands of smaller GPUs. Millions of GPUs to distribute work across all of that and to balance the workload so that you can get the most energy efficiency, the best computation time, keep your costs down. And so those fundamental innovations is what got us here. And here we are, as we see the miracle of ChatGPT emerge in front of us, we also realize we have a long ways to go. We need even larger models. We're going to train it with multimodality data, not just text on the internet, but we're going to train it on text and images and graphs and charts. And just as we learn, watching TV. And so there's going to be a whole bunch of watching video so that these models can be grounded in physics, understands that an arm doesn't go through a wall. And so these models would have common sense by watching a lot of the world's video combined with a lot of the world's languages. They'll use things like synthetic data generation, just as you and I do. When we try to learn, we might use our imagination to simulate how it's going to end up, just as I...
Exacto. Al haber más GPUs, se podrán coger, en vez de prompts, en vez de códigos, coger vídeos. ¿Vale? Cogemos millones de vídeos en diferentes idiomas, tal y como ha dicho Wong, y entrenamos la IA basándose en vídeos. La entrenamos en audio, la entrenamos en vídeos, con los subtítulos, la entrenamos en lectura. Es precioso. Sí, señor. Sí, señor. Más aún si le entrenamos tutoriales de hacer juegos, tutoriales de construir. Y luego hacer un montón de simulaciones de todo. O sea, yo qué sé. Pongo mi peso. Pongo lo que
As I
sé,
was
más o
simulating
menos.
how this keynote was going to turn out, somebody
O sea, pongo mi peso. Hay gracioso porque creo que había una empresa, no me acuerdo cómo se llama, que quería hacer simulaciones de situaciones de persona, ¿no? Por ejemplo, pongo mi peso, pongo mi tal, y la IA te simulaba y te decía, yo qué sé, si me enfrento a un ladrón, tal, y la IA te decía el resultado, basándose en tu peso, en las posibilidades y en todo eso. Muy gracioso, muy gracioso. Pues imaginaros hacer una simulación en 3D en un Real Engine, ¿no? Por así decirlo, con, ¿cómo te diría? Todas las posibilidades que tienes y escoger la mejor para la situación. Imaginaros, para cosas así en concreto, o para hacer planes o para lo que sea, brutal,
did say
brutal.
that another performer did her performance completely on a treadmill so that she could be in shape to deliver it with full energy. I didn't do that. If I get a little winded about 10 minutes into this, you know what happened. And so where were we? We're sitting here using synthetic data generation. We're going to use reinforcement learning. We're going to practice it in our mind. We're going to have AI working with AI, training each other, just like student and teacher debaters. All of that is going to increase the size of our model.
También
It's
se va a
going to increase
entrenar
the amount,
entre ellas
of,
la
the
IA.
amount of data that we have, and we're going to have to build even bigger GPUs. Hopper is fantastic, but we need bigger GPUs. And so, ladies and gentlemen, I would like to introduce you to a very, very big GPU.
A ver, a ver, a ver.
Named after David Blackwell, a mathematician, game theorists, probability. We thought it was a perfect name. Blackwell, ladies and gentlemen, enjoy this.
Va. Blackwell. No está mal. David Blackwell, es verdad. Blackwell GPO. Uf. El motor de la nueva industria de la revolución. Two Blackwell GPU and one Grace GPU. 200 GB, ok. Hostia, chaval. Están metiendo lo más de lo más. Bluefield 3. Hostia, me cago en todo, chaval. ¿Viste todo lo que tiene eso? Esto es una locura. Esto es una locura. Esto es una locura.
Comemos hoy, ¿no?
No sé. ¿Qué pasa?
¿Qué estás en directo?
Sí, me mandado WhatsApp. Únete a verlo, bro. Esto es la hostia.
¿Qué?
Es la GTC. Me están enseñando cómo es la futura tarjeta gráfica. Me han enseñado un poco lo que han generado. Van a usar IA para simular IA. En los juegos, por ejemplo, van a hacer un juego en el futuro que es que tú entras en el juego, te creas al personaje y ya la IA utiliza los enemigos, las personas y todo para hacer la historia según vas escribiendo o vas hablando con ella. El juego perfecto. Eso en los juegos. Se pueden hacer simulaciones de construcción. El futuro es que se reduzcan las horas de trabajo, ¿vale? Y que la IA haga lo más jodido. en general en todos los trabajos, porque ya aquí va a haber un avance de ella con robótica.
Se supone que sí.
Hombre, no sé, pero yo estoy viendo los avances, cómo están avanzando y ahora están enseñando esta GPU que tiene lo más moderno, muy pequeñito. Luego se meten 4 o 5 en otra así. Luego se meten otros, estas 4 o 5 en otro más grande. Se meten otro. Ahí, ¿cuánta memoria hay? Ahora mismo han hecho GPU que tiene 30 billones de memoria que están entrenando la IA con ella. Ahora mismo ChatGPT 4 tiene 1,4 billones o así en memoria entrenada. No me acuerdo cuánto.
Joder.
O sea que va a venir potencia pura. Lo que tienes que hacer es ponerte el desayuno, levante 20 y entrar a ver el directo. Porque esto es la página, hostia, no. Más tarde. Tú también.
Hay que hacer algo.
También más tarde. Esto es más importante. Es la IA. Vamos, vente, vamos a verlo.
Dale. Dale.
¿Eh?
Dale, si yo me quedo aquí viendo, me echo el corto.
Si te echo el cuento, no. No vas a escuchar, bro. Es que si me quito esto, los cascos, lo que va a pasar es
¿Pero está en
que
inglés o en español?
he puesto subtítulos. Pero ¿qué quieres, tío? El año que viene vamos a ir a esto. Yo quiero ir a esto.
¿A dónde?
A la GTC en Massachusetts.
En Massachusetts.
Massachusetts, coño.
Massachusetts.
Bueno, ¿qué más da? A tope. Vamos a verlo, vamos a seguir viéndolo, ¿vale? Esto es una bestia. Literal, esto es una bestia. Un switch para intercalar, ¿vale? Para intercalar y que todos interactúen entre ellos. Esto es lo normal, pero con una potencia inhumana. Por ahí van los cables. Enfriados con refrigeración líquida. Wow. Esto es una locura. Es una locura. ¡Dios mío! 32.000 GPUs. ¡Tócate los huevos! Espera un momento. Buah, chaval, esto es una bestia. Te mete. ¿Qué cojones, tío? Esto es una puta bestia. ¿Cuánto vale eso? Yo me
Blackwell is
pregunto.
not a chip. Blackwell is the name of a platform.
Sí, así es.
People think we make GPUs, and we do, but GPUs don't look the way they used to. Here's the if you will, the heart of the Blackwell system, and this inside the company is not called Blackwell; it's just a number, and this is Black.
Madre mía del Señor. Esta mierda en tu PC no es inhumano, o sea, es... Bueno, ahora quizá en el futuro yo estoy diciendo aquí que es la hostia, pero en el futuro esto va a ser...
Blackwell sitting next to, this is the most advanced GPU in the world in production today.
Así es. Ese es Popper, ¿no?
This is Hopper. This is Hopper. Hopper changed the world. This is Blackwell.
Joder, chaval. Es que no es muy grande, pero es que la Blackwell tiene el sistema de varias de la derecha.
It's okay, Hopper.
Madre mía.
You're very good. Good boy. Oh, good girl. 208 billion transistors.
Mil
And
millones
so
de
you can
transistores.
see, I can see there's a small line between two dies. This is the first time two dies have abutted like this together in such a way that the two dies think it's one chip. There's 10 terabytes of data between it, 10 terabytes per second. So that these two
10 Nosotros tenemos, por ejemplo, en velocidad de internet ha hecho una comparación. Nosotros tenemos la fibra, ¿no? 1000 megas, que es 1 giga por segundo. Esto tiene 10 teras. 1 tera son 1000 gigas. Y eso tiene 10 teras por segundo de reprocesamiento y de descarga. Me cago en la puta.
There's no memory locality issues, no cache issues. It's just one giant chip.
La madre que me parió. Dios, chaval. 10 teras por segundo.
The engineer said, "So what?"
Ay, la descompresión, ahí lo pone 800 gigas por segundo. Me cago en todo, es una
And it
bestia.
goes into two types of systems. The first one is form fit function compatible to Hopper. And so you slide on Hopper and you push in Blackwell. That's the reason why one of the challenges of ramping is going to be so efficient. There are installations of Hoppers all over the world, and they could be the same.
Algún día voy a poner en este armario
The power, the electricity,
o en otro,
the
depende
software,
de cómo vaya el futuro donde viva, pero voy a intentar conseguirme un par de esas.
version for the current
Meterlas ahí,
HGX configuration.
cableado,
And this is
a un PC de mierda. Y el PC de mierda va a ser la puta hostia.
And Janine, could I just borrow?
El PC de mierda va a explotar,
Ladies and
pero
gentlemen,
no porque se ha calentado, vaya mal. El PC de mierda va a explotar porque está alucinando de la potencia que va a tener.
This is a fully functioning board, and I'll just be careful.
Me
here.
cago en todo, tío. Mira qué potencia.
right here
Y
is,
conectados a la
I don't know,
Hopper.
$10 billion.
Es barato.
The second one's 5.
Claro, 5 no está mal. 5 millones así.
It gets cheaper after that. So, any customers in the audience, it's okay.
No puedo pillarme eso. Ya.
All right, but this
Lo
is
podemos
this is
robar,
more
somos
expensive. This is
romanos.
the bring up board, and the way it's going to go to production is like this one here, okay? And so you're going to take this. It has two Blackwell chips and 4 Blackwell dies connected to a Grace CPU. The Grace CPU has a super fast
Ahí está la
chip-to-chip
IA.
link.
La
What's
Grace es la
amazing
IA.
This computer is the first of its kind where this much computation, first of all, fits into this small of a place. Second, it's memory coherent. They feel like they're just one big happy family working on one application.
No se intercalan,
together.
está bien
And so
optimizado.
everything is coherent.
No como el
within
PC
it.
del Chocas,
Just the amount of,
que quería aventar
again,
2 en
use of
1
the
y no lo han
numbers. There's a lot
limpiado
of
bien el que se lo ha
terabytes this and
hecho.
terabytes that.
Pero esto
But
está
this
bien
is a
limpiado.
round. This is this. Let's see. What are some of the things on here? There's
Va.
NVLink on top, PCI Express on the bottom. On your
Es que brilla y
which
todo,
one is
tío. Mira
mine
qué
on your
bonito.
left? One of them, it doesn't matter. One of them is a CPU chip-to-chip link. Is my left or your, depending on which side. I was
5
just- I
millones.
was trying to sort that out, and I just kind of doesn't matter.
Eso es lo que vale. 5 millones.
Hopefully, it comes plugged in. So
Te vendrá enchufado, viene con enchufe. Eso es lo bueno. Pero eso,
okay,
tío,
so this is the
en
Grace
una Play o en lo
Blackwell
que
system.
sea, es que no. Te va todo, chaval. Un edificio entero. No, varios edificios enteros pueden usar esa mierda. Sin exagerar, o sea, es
So
brutal.
it turns out, all of the specs is fantastic, but we need a whole lot of new features in order to push the limits beyond, if you will, the limits of physics. We would like to always get
Sí.
a lot more X factors.
Así
And
es.
so one of the things that we did was we invented
El
another
tío ha dicho, no, pero en el futuro será más barato.
transformer engine, the second
Ya
generation.
veremos, chaval.
It has the ability to dynamically and automatically rescale
Ahora van a enseñar el transformador,
numerical formats to a lower precision.
que es lo que va a
whenever
poder
it can.
enseñar a la IA y a toda la
Artificial
GPU,
intelligence is
las
about
cositas.
probability. And so you kind of have, 1.7, approximately 1.7 times approximately 1.4 to be approximately something else. Does that make
Okay.
sense? And so the ability for the mathematics to retain the precision and the range necessary in that particular stage of the pipeline, super important. And so it's not just about the fact that we designed a smaller ALU. It's not quite, the world's not quite that simple.
Vale.
You've got to figure out when you can use that across a computation that is thousands of GPUs.
Bueno, el caso es que quieren
It's
coger
running
esta
for
mierda
weeks and weeks on weeks.
y meter
We wanna make
unas,
sure
yo qué
that
sé,
the-
10.000 y pico
the
GPUs.
training job is
O sea,
gonna
10.000 y pico de
And
esas
so
que
this
trabajen
new
en
transformer
conjunto.
engine, we have a 5th generation NVLink. It's now twice as fast as Hopper, but very importantly, it has computation in the network. And the reason for that is because when you have so many different GPUs working together, we have to share our information with each other. We have to synchronize and update each other. And every so often, we have to reduce the partial products and then rebroadcast out the partial products, the sum of the partial products, back to everybody else. And so there's a lot of what is called all reduce and all to all and all gather. It's all part of this
Van a
area
sacar
of
una puta
synchronization and
bestia, tío.
collectives so that we can have GPUs working with each other. Having
Una puta bestia.
extraordinarily fast links and being able to do mathematics right in the network allows us to essentially amplify even further. So even though it's 1.8 terabytes per second, it's effectively higher than that.
1,8
And so it's many
teras.
times that of Hopper. The likelihood of a supercomputer running for weeks on end is approximately 0. And the reason for that is because there's so many components working at the same time. The statistic, the probability of them working continuously is very low. And so we need to make sure that whenever there is we checkpoint and restart as often as we can, but if we have the ability to detect
Hostia, eso tiene que
a
consumir
weak
una
chip or a
electricidad.
weak node early, we could retire it and maybe swap in another processor. That ability to keep the utilization of the supercomputer
O sea, que aún tiene que
high,
pensar-
especially when you just
Vamos, que aún tienen que pensar en una forma de darle potencia a todo esto. Para que vaya
spent $2
bien.
billion building it is super important. And so we put in a
O sea, que han
RAS
gastado ya
engine, a
2.000
reliability
millones
engine
para
that does
construir
100% self-test, in-system test of every single gate, every single bit of memory on the Blackwell chip and all the memory that's connected to it. It's almost as if we shipped with every single chip its own advanced tester that we test our chips with. This is the first time we're doing this. Super excited about it. Secure AI. Only this conference do they clap for RAS. The secure AI. Obviously, you've just spent hundreds of millions of dollars creating a very important AI, and the code, the intelligence of that AI is encoded.
¿Sabes lo gracioso? Que cuando salga esta IA, habrá una, pero que todo el mundo la podrá utilizar a la vez.
In the parameters.
Ya sea para
You wanna
jugar,
make
ya
sure
sea
that on the
para
one hand, you don't lose it. On the other hand,
hacer
it doesn't
simulaciones de
contaminate it.
cosas.
And so
Podremos
we now have the
prevenir
ability
un montón de
to
cosas con esto, tío.
encrypt data, of
Podemos
course, at
coger la
rest,
IA
but also in transit
y hacer un cálculo muy realista sobre posibles tsunamis, cómo tendríamos que hacerlo.
And so we now
Una
have the
guía
ability to
total.
encrypt in transmission,
Una
and
facilidad
when we're
enorme para
computing
todo.
it is in a trusted environment, trusted engine environment. And the last thing is decompression.
Y la seguridad tampoco sería
Moving
mucho
data in and
problema.
out of these nodes, when the
Porque,
compute is so fast, becomes
Estos
really
quieren
essential.
entrar también la IA para
And so we
defenderse,
put
por
in
así
a
decirlo.
high line speed compression engine, and it effectively moves data 20 times faster in and out of these computers. These computers are so powerful, and there's such a large investment. The last thing we want to do is have them be idle. And so all of these capabilities are intended to keep Blackwell fed and as busy as possible. Overall, compared to Hopper, it is 2.5 times the FP8 performance for training per chip. It also has this new format called FP6, so that even
Bueno, no
though the
está mal,
computation speed
2,5
is the
veces
same,
mejor, 5
the
veces mejor,
bandwidth that's
6.
amplified
Ah.
because of the memory, the amount of parameters you can store in the memory is now amplified. FP4 effectively doubles the throughput. This is vitally important for inference.
Lo duplica, no, coño, es 5 veces mejor.
Is becoming very clear is that whenever you use a computer with AI on the other side, when you're chatting with the chatbot, when you're asking it to review or make an image, remember, in the back is a GPU generating tokens. Some people call it inference, but it's more appropriately generation. The way that computing is done in the past was retrieval. You would grab your phone, you would touch something, some signals go off, basically an email goes off to some storage somewhere. There's pre-recorded content, somebody wrote a story or somebody made an image or somebody recorded a video. That pre-recorded content is then streamed back to the phone and recomposed in a way, based on a recommender system, to present the information to you.
Bien explicado, sí.
You know that in the future, the vast majority of that content will not be retrieved. And the reason for that is because that was pre-recorded by somebody who doesn't understand the context, which is the reason why we have to retrieve so much content. If you can be working with an AI that understands the context, who you are, for what reason you're fetching this information, and produces the information for you, just the way you like it.
Lo que te dicen los juegos.
The amount of energy we save, the amount of networking bandwidth
El
we save,
juego
the amount
perfecto.
of wasted time we save will be tremendous.
Buah, es que
The
sería el
future
juego
is
perfecto
generative, which is the reason
que se
why
crea a la
we're
medida
generative
para
AI.
ti y hasta no tendría final ese juego, el juego infinito. O sea, es que qué mierda, tío.
Is fundamentally different.
Sería una puta revolución ese juego si lo
For the
logran
generative
en
AI
el futuro.
era.
Yo lo espero en el
And one of
juego
the most important parts of
y que
it
faciliten las
is
cosas,
content
que
token
reduzcan las horas de
generation.
trabajo, que
We
la IA
call
lo haga
this
todo en
format
general.
as FP4.
¿Qué cojones?
Well, that's a lot of computation. 5x the token generation, 5x the inference capability of Hopper seems like enough. But why stop there?
Exacto.
The answer is it's not enough, and I'm going to show you why. I'm going to show you why. And so we would like to have a bigger GPU, even bigger than this one.
Ok.
And so
No puede
we
ser.
decided to scale it. And notice, but first, let me just tell you how we
¿Cómo que
scale.
escalarlo?
Over the course of the last 8 years, we've increased computation by 1,000 times. 8 years, 1,000 times. Remember, back in the good old days of Moore's Law, it was 2x, well,
Esto es una
5x
puta
every,
locura.
what, 10x every 5 years. That's easiest math. 10x every 5 years, 100 times every 10 years. 100 times every 10 years in the middle, in the heydays of the PC revolution.
Desde 2016,
100 times every 10 years. In the last 8 years, we've
¿ves el
gone
aumento que ha
1,000
pegado
times.
la
We
IA,
have 2 more
tío?
years to go. And so that puts it in perspective. The rate at which we're advancing computing is insane, and it's still not fast enough, so we built another chip.
Sigue sin ser rápida.
It's just an incredible chip. We call it the NVLink switch.
Envy.
It's 50 billion transistors. It's almost the size of Hopper all by itself. This switch chip has 4 NVLinks in it, each 1.8 terabytes per second, and it has computation in it, as I mentioned. What is this chip for?
Me encanta.
If
Me
we were to
encanta que
build such a chip,
evolucionen las cosas, tío. Es lo mejor.
we can have every single GPU talk to every other GPU at full speed at the same time. That's insane.
Puta Nvidia.
doesn't even
Voy a
make
comprar
sense.
acciones de Nvidia. Cuando cobre
But
este
if you
mes,
could do
compro
that,
acciones.
if you can find a way to do that,
Al menos
and
una.
build a system to do that, that's cost effective. That's cost effective. How incredible would it be that we could have all these
Esto es una puta señal.
GPUs connect over
Esto es
a
una puta
coherent
fucking señal.
link so that they effectively
Una
are one
señal.
giant GPU.
Tengo que
Well,
pillar.
one of the great inventions
Al
in
menos
order
una
to make it
acción.
cost effective is that this chip has to drive copper directly. The SerDes of this
Y
chip
encima ha
is
dicho
just
cobre.
a
Ya
phenomenal
está.
invention. so that we could do direct drive to copper. And as a result,
Dos veces.
you can build a system that looks like this.
A ver. Es que uno solo de estos, tío, es bonito, tío. Enchufarlo eso al PC.
Now this system
¿Eso cuánto vale? 10
is kind of
millones.
insane.
Es el
This
DGX.
is one DGX. This is what a DGX looks like now. Remember, just 6 years ago, it was pretty heavy.
La primera
It was
IA
able to lift it.
salió en 2016 y es el DGX. Lo único que ellos lo que han hecho es mejorarlo y entrenarlo para que intercale todas las GPUs y trabajen todas a un mismo ritmo, que reciban la misma velocidad, que manden la misma velocidad, la misma cantidad de información entre ellas, ¿sabes? Que sea igual, de normal un PC no coge todo el internet que manda el router, es que lo enchufes directo. Pues esto es, lo que ellos quieren hacer es sacar todo el jugo, sacar toda la potencia de la IA. Exacto, la primera versión fue 0,17. Me cago en la puta, tío. Teraflops, lo han llamado teraflops de forma graciosa. En realidad son... Bueno, es más grande que el tera, por así decirlo, ¿no? Lo han llamado teraflops por hacer la gracia. Lo ha dicho al principio del vídeo el tío. Luego dejaré el vídeo este en la descripción para que le echéis un vistazo. Así es.
And so this is an exaflops AI system in one single rack. Well, let's take a look at the back of it.
Es impresionante. Encima esa conexión entre todas las demás está manejado por una IA. Y ahora nos lo van a enseñar.
NVLink spine, 130 terabytes per second.
130 teras por segundo.
Chassis. That is more than the aggregate
Os
bandwidth
recuerdo
of the internet.
que nosotros tenemos 1 giga de normal de internet, que son 1000 megas, y 1 tera son 10 gigas.
We could basically
Era, ¿no?
send everything to everybody within a second. And so we have
130 teras, es que es...
5,000 NVLink cables, in total 2 miles. Now this is the amazing thing. If we had to use optics, we would have had to use transceivers and retimers, and those transceivers and retimers alone would have cost 20,000 watts.
O sea que han pensado en el gasto también, ¿eh?
Just to drive the NVLink spine. As a result, we did it completely for free over NVLink switch, and we were able to save the 20 kilowatts for computation. This entire rack is 120 kilowatts, so that 20 kilowatts makes a huge difference. It's liquid cooled. What goes in is 25 degrees C, about room temperature.
Okay.
What comes out is 45 degrees C, about your jacuzzi. So room temperature goes in, jacuzzi comes out, 2 liters per second.
No está mal. No gasta mucho, ¿no? Bueno, gasta mucho. Pero teniendo en cuenta la escala de las cosas, lo veo bastante bien. No está mal, no está mal.
600,000 parts. Somebody used to say, you know, you guys make GPUs, and we do, but this is what a GPU looks like to me. When somebody says GPU, I see this. 2 years ago, when I saw a GPU, it was the HGX. It was 70 pounds, 35,000 parts. Our GPUs now are 600,000 parts and 3,000 pounds. 3,000 pounds. 3,000 pounds, that's kind of like the weight of a, you know, carbon fiber
1000 kilos
Ferrari.
de GPU.
I don't know if that's useful metric, but
Más o menos, 1 tonelada, por ahí.
everybody's going, I feel it, I get it.
Buah, imagínate tener eso ahí en el armario, corriendo, ¿eh? Qué bonito. Yo no me compraría un Ferrari
Okay, so 3,000
si me toca la
pounds.
lotería o algo. ¿Qué cojones? Me compro una GPU de estas chetadas.
So this is what a DGX looks like. Now let's see what it looks like.
Dejo una ciudad sin
Okay,
luz.
let's imagine. How do we put this to work, and what does that mean? Well, if you were to train a GPT model,
No, aunque pudiera comprarla, no podría darle yo potencia, ¿eh?
It took about apparently
Tendría que llamar a la
3 to 5
eléctrica
months or so,
y
with
ver cómo se puede hacer.
25,000 amperes.
25.000
If we were
amperios
to do it
con
with
la
copper,
energía.
it would probably take something like 8,000 GPUs, and it would consume 15 megawatts. 8,000 GPUs and 15 megawatts. It would take 90 days, about 3 months. And that would allow you to train something that is, this groundbreaking AI model. And this is obviously not
Bueno,
as
ahora nos
expensive
están explicando
as anybody would think, but it's
lo que
8,000
tiene la IA,
GPUs.
cómo
It's still
funciona, los
And
gastos,
so
lo que han
8,000
hecho,
GPUs, 50
los
megawatts.
avances.
If you were to use Blackwell to do this,
Y ahora en cerquita nos enseñará lo que puede hacer esto, más o menos. O sea que no...
2,000 GPUs, same 90 days, but this is the amazing part. Only 4 megawatts of power. So from 15, yeah, that's right.
Buena reducción de gasto, ¿eh? Buena reducción de gasto.
And that's our goal. Our goal is to continuously drive down the cost and the energy. They're directly proportional to each other, cost and energy associated with the computing, so that we can continue to expand and scale up the computation that we have to do to train the next generation
Esto van a
models.
meter una IA para todo, vais a verlo. Van a coger la IA y van a decir, van a entrenar una IA expresamente para que la IA controle el gasto de su propia infraestructura, para que se cuide ella misma mejor, con un poco de toqueteo por detrás para que no se pete.
All these different models that are being used when you're interacting with it, or generating images, or generating videos, generating proteins, generating chemicals. There's a bunch of generation going on. All of that is in the category of computing we call inference. But inference is extremely hard
Complicado,
for
pero
large models because
yo también quiero
these
uno
large
para
language models have
Navidades.
several properties. One, they're very large, and so it doesn't fit on one GPU. This is, imagine Excel doesn't fit on one GPU, and imagine some application you're running on a daily basis doesn't fit on one computer, like a video game doesn't fit on one computer, and most, in fact, do. And many times in the past, in hyperscale computing, many applications for many people fit on the same computer. And now, all of a sudden, this one inference application where you're interacting with this chatbot, that chatbot...
Posiblemente en el futuro, una cosa que se va a valorar mucho es el valor del diseño, por así decirlo. La creatividad del ser humano. Si las cosas avanzan bien y no hay problemillas y lo sacan todo, yo creo que lo que más se va a valorar es la imaginación, la forma de instruir a las IAs. Se puede influir bastante. A ver cómo avanza esto en los sectores más jodidos, que son los sectores donde se necesita mano humana, por así decirlo. A ver si logramos quitar la mano humana de los trabajos peligrosos. Espero que se hayan fijado en eso en el futuro. Del vídeo, claro. Si se han fijado en eso y logran quitar trabajos forzados y esas cosas, no hay por qué negarlo, qué cojones. Ya si las cosas tienen buen camino y hay buen plan de avance y se logra quitar trabajos así de mana y tal, es una muy buena apuesta seguirle el camino a la IA. ¿Cómo que no va bien, hombre? Mis ánimos. Ah, bueno, está...
And so here we are, we're trying to generate these tokens, and when you're interacting with it, you're hoping that the tokens come back to you as quickly as possible and as quickly as you can read it.
Una respuesta rápida, ¿no?
For generation tokens is really important.
Básicamente un token es que cuando tú le mandas un mensaje, te genera un número como un ticket que le llega a la IA y la IA te tiene que contestar lo más rápido posible.
Because that throughput reduces the cost, the overall cost per token of generating. So your throughput...
Y todo eso tiene un coste, pero no de dinero, sino de memoria, de datos, que la GPU tiene que guardar y tratar. No, porque hay que tener en cuenta que somos muchas personas en el mundo, y si todas hablaran a la vez con la IA, podría surgir algún problemilla. Y creo que esto lo quieren prevenir.
Compete against each other. And we have to find a way to distribute work across all of these different GPUs and parallelize it in a way that allows us to achieve both.
Yo
And
como
it
un
turns
general,
out
hay
the
que
search-
comandar
the
mejor
search
el
space is
ejército
enormous.
para que todo se conteste
You
rápido.
know, I told you there's going to be math involved. And everybody's going, oh, dear.
La matemática, ya, amigo, ya
I heard
sabía.
some gasps just now when I put
La
up that
dicha,
slide.
¿eh?
You know, so this right here, the
A ti te gustan las
y-axis is
mates,
tokens per
¿no?
second, data center throughput. The x-axis is tokens per second, interactivity of the person. And notice the upper right
Ese es
the
el
best.
cálculo
You want
del
interactivity to be very
GPT-4,
high.
¿vale? Este es el GPT-4.
Number of tokens per second per user. You want the
Y
tokens
lo han
per
ido
second
reduciendo los
per data
gastos.
center to be very high. The upper right is terrific. However, it's very hard to do that. And in order for us to search for the best answer across every single one of those intersections, XY coordinates, okay, so just look at every single XY coordinate, all those blue dots came from some repartitioning of the software. Some optimizing solution has to go and figure out whether to use tensor parallel, expert parallel, pipeline parallel, or data parallel.
Esto ya no
and
tengo mucha idea,
distribute
lo siento,
this enormous model across all these
Pero ya esto de los
GPUs
cálculos
and
y las
sustain
matemáticas a mí se me
performance
dan
that we
mal.
need. This exploration space would be impossible if not for the programmability of NVIDIA's GPUs. And so we could, because of CUDA, because we have such a rich ecosystem, we could explore this universe and find that green roof line. It turns out that green roof line, notice, you got TP2, EP8, DP4. It means two tensor parallel.
No,
tensor
no,
parallel
no, te
across
estás
two
explicando
GPUs,
fatal.
expert parallels across 8, data parallel across 4. Notice on the other end, you got tensor parallel across 4 and expert parallel across 16.
No, no, esto ya es para
The
técnicos
configuration,
informáticos.
the distribution of
Lo
that
entenderían
software,
mejor.
it's a
Yo soy programador.
different
Si no
runtime
me código.
that would produce these different results. And you
Si
have to go
enseñan
discover
código, yo
that
os lo
roof
explico
line.
más o
Well,
menos.
that's just one model.
Explico
And
más o
this is
menos.
just one configuration of a computer. Imagine all of the models being created around the world and all the different configurations of systems that are going to be available. So now,
Hombre, se puede
that you
combinar,
understand
¿no?
the basics,
Que generen
let's
una IA
take a
madre
look at
o varias
inference
IAs madre
of
que se
Blackwell
encarguen
compared to
de mover y almacenar y de
This is-
crear
this is the
diferentes IAs
extraordinary thing.
que se encarguen de cada
one
persona en
generation,
su...
because we created a
en su
system
propio
that's designed for trillion parameter generative
mundillo que se
AI.
crea la gente, ¿no?
The
Por así
inference
decirlo.
capability of Blackwell is off the charts.
Que tenga cada uno ahí... Bueno,
And in
sí,
fact,
se podría
it
decir
is
así.
some 30 times
No, pero
hotter.
lo que yo digo es una destrucción de memoria. Sería lo más eficiente y lo más bonito, pero sería también lo más desastre para la GPU.
For large language models like ChatGPT and others like it,
Tiene muy buena
the
idea.
blue line is Hopper.
Pero ya lo ha
Again,
dicho antes,
imagine
darle
we didn't
potencia a
change
todo
the
esto,
architecture
tío.
of Hopper, we just made it a bigger chip. We just used the latest, greatest.
Todo lo que está diciendo tiene un muy buen futuro, muy buen uso y tal. Ahora mostrará algo con lo que ya tienen entrenado. Pero para llenar todo eso y entrenar todo eso, muchos años.
10
Necesitaremos otro salto.
We connected the two chips together. We got this giant 208 billion parameter chip. How would we have performed if nothing else changed? And it turns out quite wonderfully, and that's the purple line, but not as great as it could be.
Bueno, aquí está
And
explicando
that's
un poco
where
cómo habríamos
the
ido.
FP4
Esto
tensor
es de
core,
antes,
the transformer engine,
un poco más de
and
avance y ahora con lo que
very
tenemos estamos
importantly,
avanzando
the
bastante
NVLink
bien.
switch. And the reason for that is because all these GPUs have to share the results, partial products. Whenever they do all gather, whenever they communicate with each other, that NVLink switch is communicating almost 10 times faster than what we could do in the past
Wow,
using
tío,
the
estás
fastest
hablando mucho.
networks.
Necesitamos un poco de vídeo para digerir, ¿no?
Blackwell
Como
is going to be
ejemplo.
just an amazing system
Como el
for
vídeo de antes.
generative AI. And in the future, data centers are going to be thought of, as I mentioned earlier, as an AI factory.
Ok,
An
los
AI
centros de
factory's
datos.
goal in
Claro.
life is to generate revenues, generate, in this case, intelligence in this facility, not generating electricity as in AC generators, but of the last industrial revolution and this industrial revolution, the generation of intelligence. And so this ability is super, super important.
Generar
The
inteligencia.
excitement of Blackwell is really off the charts. When we first when we first, this is a year and a half ago, 2 years ago, I guess 2 years ago, when we first started to go to market with Hopper, we had the benefit of two CSPs joined us in a launch, and we were, delighted. And so we had 2 customers. We have more now.
2 clientes tenía. Está contando un poco el principio de todo esto, ¿eh? Ahora tiene más clientes. Mira, estos son todos los clientes de Nvidia, ¿eh? Se la están sacando Meta, Adept, OpenAI, conocemos Asus, lo conocemos, Gigabyte, esa me suena de nuevo. ¿Cuál más conocemos? X, de Twitter. Están usando esto también, Tesla. Microsoft Azure, Google Cloud, Amazon, Lambda, hostia, chavales. Cisco, he trabajado con Cisco, sí.
Unbelievable excitement.
Yo invertiré en Nvidia.
And there's a whole bunch of different
Nada más
configurations.
cobrar voy a coger y voy a invertir algo ahí. Tiene muy buena pinta. Tenía que haber visto esto el 18 de marzo, cuando ha salido.
That's connected by NVLink 72. Blackwell is going to be ramping to the world's AI companies, of which there are so many now, doing amazing work in different modalities. The CSPs, every CSP is geared up. All the OEMs and ODMs, regional clouds, sovereign AIs, and telcos all over the world are signing up to launch with Blackwell.
Qué bonito, tío. Se han juntado tantas empresas. Han metido todas juntas dinero para sacar esto adelante, ¿eh? ¿Cómo se nota la pasión, eh? Y yo voy a apoyar, ¿eh?
AWS is gearing up for Blackwell. They're going to build the first GPU with secure AI. They're building out a 222 exaflops system. Just now when we animated the digital twin, if you saw all of those clusters are coming down. By the way, that is not just art, that is a digital twin of what we're building. That's how big it's going to be. Besides infrastructure, we're doing a lot of things together with AWS. We're CUDA accelerating SageMaker AI. We're CUDA accelerating Bedrock AI. Amazon Robotics is working with us using Nvidia Omniverse and Isaac Sim.
Nvidia Omniverse, que antes lo ha dicho, Nvidia Omniverse es un mundo virtual en donde ahí es donde están entrenando los robots de OpenAI, los robots de todo. Están haciendo simulaciones, están creando una calle, no tienen gráficos de la hostia para ahorrar memoria y tal, pero hacen el robot paseando por la calle con un coche, el robot de tal. Lo único que seguramente no estarán teniendo en cuenta son que si le pegan una hostia a un robot, un ser humano, o si el robot está llevando algo, un paquete o lo que sea, y el humano se lo roba. Eso no lo están teniendo en cuenta. Porque, no sé, creo que tienen la cabeza que se piensan que es todo bonito. Siempre hay cosas que hay que tener en cuenta. Y eso va a pasar. Vosotros pensáis, oh no, tal. Pero sí, habrá gente que dirá, hostia, la IA nos va a quitar curro y tal. Parte va a quitar curro, pero nosotros nos adaptamos. Mejor adaptarse al avance que adaptarse al desavance. Yo pienso eso. Yo no voy a ver, yo si veo un robot repartiendo algo, lo que sea, yo me voy a alegrar en parte. O si veo que está haciendo algo por la calle, tal. Porque es un avance, ¿no? Está aligerando la carga del trabajo a las personas. No tenemos que pensar que nos quitan el trabajo. Tenemos que buscar una forma de adaptarnos. A ver cómo lo harán los gobiernos ante tanta evolución. Eso es lo principal. ¿Vale? Los gobiernos que son nuestros trabajadores, que nosotros somos los que les pagamos. Habría que ver cómo entonces, con eso, porque las simulaciones están en constante entrenamiento. con la IA,
Google is
con los
gearing up for
coches,
Blackwell.
con las
GCP
construcciones,
already has
con todo.
A100s, H100s, T4s, L4s, a whole fleet of Nvidia CUDA GPUs, and they recently announced the Gemma model that runs across all of it. We're working to optimize and accelerate.
Google está entrenando el
every
modelo
aspect of
Gemma,
GCP.
por así
We're
decirlo.
accelerating data proc, which for data processing, their data
Pero
processing
va a hacer
engine,
lo
JAX,
mismo. Se llame como se llame.
Vertex AI,
Antes hemos
and
visto
Joko
todas las
for a while.
empresas que
So
está
we're
trabajando con
working with,
Nvidia y
Google
todas
and
van a
GCP
estar
across a whole
intercaladas
bunch
con la
of
memoria.
initiatives. Oracle is gearing up for Blackwell. Oracle is a great
Oracle
partner of
también.
ours for Nvidia DGX Cloud, and we're also working together to accelerate something that's really important to a lot of companies, Oracle Database.
Microsoft también.
Microsoft is accelerating, and Microsoft is gearing up for Blackwell. Microsoft and NVIDIA has a wide-ranging partnership. We're accelerating CUDA, accelerating all kinds of services when you
Se viene
chat,
más
obviously,
potencia en
and,
todo en general.
AI services
Si no
in
sacan la
Microsoft
potencia,
Azure, it's very likely NVIDIA's in the back,
2025-2026, si
doing the
no
inference and
sacan la
token
potencia es porque
generation.
quieren perder lo anterior. Y yo creo que van a hacer eso. Al fin y al cabo el dinero es lo que ciega a la gente. Pero esa potencia en un par de años tendría que estar con el avance que estamos teniendo.
NVIDIA Omniverse is now hosted in Azure. NVIDIA
Tenemos que verla ya la potencia
and
esa.
all of it is deeply integrated and
Más
deeply
os vale
connected
fucking bitches.
with Microsoft
Voy
Fabric.
a comprar acciones, pero no para hacerme yo rico, sino para apoyar.
This is what I'm about to show you. Most of
Algo me
most
llevaré
of
de beneficio. Pero bueno, eso es lo de menos.
scenes that you've seen so far of Blackwell are the full fidelity design of Blackwell. Everything in our company has a digital twin. And in fact, this digital twin idea is
Eso del gemelo digital lo que han hecho es básicamente coger todos sus datos y meterlo en un gemelo en la nube.
And what could be more exciting than
Tienen fe en la IA.
creating a digital twin to build a computer that was built in a digital twin? And so let me show you what Wistron's doing.
Vale, vamos
To
a ver.
meet the demand for NVIDIA accelerated computing, Wistron, one of our leading manufacturing partners, is building digital twins of NVIDIA DGX and HGX factories using custom.
Esto es un gemelo digital que han hablado, ¿vale? Han creado el edificio en sí en la IA, lo veo como un mal gasto de memoria, ¿eh? Un poco mal gasto, pero bueno, que lo han construido ahí y han hecho un ordenador dentro del ordenador. No sé si me explico. Imagínate que tú coges tu ordenador, tienes esta memoria y tal, pero dentro del ordenador creas un ordenador más potente. Eso es lo que nos van a mostrar ahora mismo. Un ordenador más potente con más memoria digital, que no sea memoria física. Para poder ahorrar espacio, para poder...
Software
No sé si me
developed with
entendéis.
Omniverse SDKs
¿Tú me
and
entiendes, no, bro?
APIs.
O sea, es...
For their newest factory,
¿Ves? Esto
Wistron
es
started with
en
a
la
digital
IA.
twin
Tú
to
coges,
virtually
entras
integrate
y te
data,
mueves en la
tag,
oficina
and
ahí
process
dentro.
simulation data into a unified view.
Y lo que están haciendo es
Testing and optimizing
básicamente
layouts in
hacerlo
this physically
digital.
accurate digital environment increased worker efficiency by 51%. During
Y han
construction,
logrado
the
aumentar un
Omniverse digital
51%
twin
la
was used to
eficiencia.
verify that the physical build matched the digital plans.
Esto es el real
Discrepancies early has
y
helped avoid
están
costly change
haciéndolo
orders.
en
And the
digital.
results have been impressive. Using a digital twin helped bring Wistron's factory online in half the time, just 2.5
Y están
months
fabricándolo
instead of 5.
digitalmente.
In operation, the Omniverse digital twin helps
Qué
Wistron
guapo,
rapidly
tío.
test new layouts to accommodate new
Tranquilo,
processes
saldrá de
or
todo.
improve operations.
Imagínate lo que le he dicho antes a Saúl con el juego ese perfecto, ¿no? El juego perfecto que tú coges, entras en el juego, la IA te va estudiando, te va conociendo y tendrás, por ejemplo, experiencias inauditas con mujeres, con la IA. Eso sí lo dejan sin censura, claro. Y mujeres robot ahora, no te preocupes, no te preocupes.
In the existing space.
Si no lo dicen aquí con la posibilidad de que esto tienen, o sea, imagínate coger tú, hacerte un gimnasio digital, levantar las cosas y que pesen de forma digital todo. Es un ejemplo para que se entienda más o menos. Es que son la puta hostia esto, tío. Hacerlo todo digital ha sido una idea impresionante. Adiós al espacio. Ya no necesitas un almacén enorme para guardar las cosas.
People ask me, how did it start?
Muy buena idea. Y cuando salga de forma física, todo va a ser precioso. ¿Por qué? Porque ya va a estar probado en la
Look at you
simulación,
guys so excited.
con datos reales de
What
simulación.
was it that you saw that caused you
¿No os
to
mola
put
esto? Tío, es la
all
puta
in
hostia, me cago en todo.
on this incredible idea? And it's this. Hang on a second.
Eso fue la primera cosa que hicieron, mira. Foto de un gato del 2012. Gato.
That's what happens when you don't rehearse.
Lo primero que han hecho, tío. Esta gran idea es lo que ha llegado a lo que hay ahora.
This, as you know, was First Contact,
AlexNet.
2012, AlexNet. You put a cat into this computer, and it comes out and it says, cat.
Es un gato, sí, gato.
And we said, oh my God, this is going to change everything. You take 1 million numbers,
Un millón de intentos para que aprenda que eso es un gato.
These numbers make no sense to anybody. You put it into this software, and it
Qué bonito, tía.
It reduces it from a million dimensions. It turns it into 3 letters, 1 vector.
Coge la imagen, la comprime y la convierte en un millón de datos, y ese millón de datos da resultado en 3 letras, para que nosotros lo entendamos.
And you could have it be the front of the cat and the back of the cat. And you look at this thing, you say, unbelievable. You mean any cats?
Sí, ahora esto reconoce cualquier gato.
And it was able to recognize all these cats. And we realized how it did it. Systematically, structurally, it's
Qué
scalable.
bonito, tía, qué buen avance.
How
Dale
can
like.
you make it?
Dale like si queréis ver más, ¿eh? Pues de
And
puta.
so we imagined that
Dale
this is a
puto like.
completely new way of writing software.
Fucking.
And now today, as you know,
Espera.
you type in the word CAT, and what comes out is a cat. It went the other way.
O sea que lo han hecho al revés también. Escribes gato y te saca un gato.
Unbelievable. How is it possible?
Eso en 2012
How is it possible
tenía que
you
ser la
took
hostia,
3
¿eh?
letters and you generated
En 2012, el año del
1
fin
million
del
pixels from
mundo.
it, and it made sense. Well, that's the miracle. And here we are, just literally 10 years later, where we recognize
Imagen,
text, we
vídeo,
recognize images, we
imagen,
recognize
3D,
videos
sonido
and
de gato,
sounds, and
animación,
images, not only do we
manipulación.
recognize them,
Buah.
we understand their meaning.
Aquí han hecho
We
una
understand the
proteína
meaning of the
digital.
text. That's the reason why I can chat with you.
Ah, y esto es
It
lo
can summarize for you.
de la tía que no puede hablar,
Understands the text.
que mueve los labios, le hace la lectura de labios y sale con voz de la mujer del avatar. Una lectura de labios. Para los ciegos también hay solución. Es la puta hostia. Me encanta el futuro.
The reason why we started with text and images is because we digitized those. But what else have we digitized? Well, it turns out we've digitized a lot of things: proteins and genes and brain waves. Anything you can digitize, so long as there's structure, we can
Falta
probably learn some
digitalizar
patterns from
emociones,
it,
no, eso.
and we can learn the patterns from
Eso
it
no
and
se va a
understand
poder.
its meaning.
Se
If we
puede
can understand
digitalizar
its meaning,
actuaciones.
we
Según
might be
tengo
able to
entendido.
generate it
Pero
as well. And so
sentimientos
therefore,
no.
the generative AI revolution is here. Well, what else can we generate? What else can we learn? Well, one of the things that we would love to learn is we would love to learn climate.
No
We
lo he
would love to
pensado.
learn extreme weather. We would love to learn how we can predict future weather at regional scales at sufficiently high resolution such that we can keep people out of harm's way before harm comes. Extreme weather cost the world $150 billion. Surely more than that, it's not evenly distributed.
Muy buena
$150
idea
billion
también,
is
¿eh?
concentrated
El
in some parts of the
tiempo.
world, and of course to some people of the world. We need to adapt, and we need to know what's coming. And so we're creating Earth 2, a digital twin of the
Ah,
Earth
qué hijos
for
de
predicting
puta.
weather.
Están creando una tierra gemela virtual
The ability to use generative AI to predict weather
para predecir
at
el
extremely
clima.
high resolution. Let's take a look.
As the Earth's climate changes, AI-powered weather forecasting is allowing us to more accurately predict and track severe storms, like Super Typhoon Chanthu, which caused widespread damage in Taiwan and the surrounding region in 2021.
Me cago en todo,
AI
qué
forecast
guapo.
models can accurately predict the track of storms, but they are limited to 25-kilometer resolution, which can miss important details. Nvidia's Cordif is a revolutionary new generative AI model trained on high-resolution, radar-assimilated WRF weather forecasts and Era 5 reanalysis data. Using Cordif, extreme events like Chanthu can be super resolved from 25-kilometer to 2-kilometer resolution, with 1,000 times the speed and 3,000 times the energy efficiency of conventional weather models.
No está
By
mal.
combining the speed and accuracy of Nvidia's weather forecasting model ForecastNet and generative AI models like Cordif,
Aún está ahí,
we can
¿eh?
explore hundreds
Perdón,
or
estoy
even
enseñando con el dedo.
thousands of
Aún está aquí
kilometer-scale
abajo
regional
la
weather
tormenta
forecasts
y está
to provide a
prediciendo
clear picture
el
of the
avance,
best,
más o
worst,
menos.
and most likely impacts of a storm. This wealth of information can help minimize loss of life and property damage. Today, Cordif is optimized for Taiwan, but soon, generative supersampling will be available as part of the Nvidia Earth 2 inference
qué
service for
bonito.
many regions across the globe.
Qué bonito, tío. Aquí sí. Buah. Imagínate que viene un tifón a España o cualquier mierda. Yo no quiero que me llegue eso. Yo me quiero ir antes de que pase eso.
First principled base of simulation. However, they're also going to integrate Earth-2 Cordif so that they could help businesses and countries do regional high-resolution weather prediction. And so if you have some weather prediction you'd like
Ah,
to
y
know,
de alta
you'd like to do,
resolución,
reach out to the weather company.
Llevarlo en baja.
Really exciting,
Hay
really
que ahorrar
exciting.
espacio.
Nvidia
Aunque no,
Healthcare.
luego la gente se queja
Something we
también.
started
Claro.
15 years ago. We're super excited about this. This is an area where we're very proud. Whether it's medical imaging or gene sequencing or computational chemistry.
Ah, eso es en pandas. Yo sé pandas, pero jodidísimo. La matemática que tiene eso. Tengo que practicarlo más, ¿eh?
That we're going to do something really cool. Imagine all of these AI models that are being used to generate images and audio, but instead of images and audio, because it understood images and audio, all the digitization that we've done for genes and proteins and amino acids, that digitization capability is now passed through machine learning so that we understand the language of life. The ability to understand the language of life, of course, we saw the first evidence of it with AlphaFold. This is really quite an extraordinary thing. After decades of painstaking work, the world had only digitized and reconstructed using cryo-electron microscopy or crystal X-ray crystallography. These different techniques painstakingly reconstructed the protein, 200,000 of them in just, what is it, less than a year or so? AlphaFold has reconstructed 200 million proteins, basically every protein, every living thing that's ever been sequenced. This is completely revolutionary. Well, those models are incredibly hard to use, incredibly hard for people to build, and so what we're going to do is we're going to build them. We're going to build them for the researchers around the world, and it won't be the only one. There'll be many other models that we create, and so let me show you what we're going to do with it.
Me cago en la puta. Me cago en la puta lo que se viene.
Virtual screening for new medicines is a computationally intractable problem. Existing techniques can only scan billions of compounds and require days on thousands of standard compute nodes to identify new drug candidates. Nvidia BioNeMo NIMs enable a new generative screening paradigm. Using NIMs for protein structure prediction with AlphaFold, molecule generation with MolMIM, and docking with DiffDock, we can now generate and screen candidate molecules in a matter of minutes. MolMIM can connect to custom applications to steer the generative process, iteratively optimizing for desired properties. These applications can be defined with BioNeMo microservices or built from scratch. Here, a physics-based simulation optimizes for a molecule's ability to bind to a target protein, while optimizing for other favorable molecular properties in parallel. MolMIM generates high-quality drug-like molecules that bind to the target and are synthesizable, translating to a higher probability of developing successful medicines faster. BioNeMo is enabling a new paradigm in drug discovery with NIMS, providing on-demand microservices that can be combined to build powerful drug discovery.
Adiós a las medicinas esas falsas que tienen efecto placebo, chaval. Esto, si se implementa, se podría controlar. Ya no se crearían enfermedades. Si se mete bien seguro esto para que nadie se meta y diga, oye, créame un virus o lo que sea. No. No podemos hacer eso. Eso mata a los humanos. Nosotros protegemos a los humanos. Esto sería la perfección. Madre mía, tía.
BioNeMo NIMS are helping researchers and developers reinvent computational drug design.
Medicina de verdad. No más mierda, coño.
MolMIM, CoreDiff, there's a whole bunch of other models.
Hasta se podría solucionar problemas, yo que sé. Hostia, tienes rodillas jodidas de por vida o algo. Se podría solucionar. Recreando. Virtualmente y luego. En personas. Me cago en todo, tío.
How would you bring it into your company and integrate it into your workflow? How would you package it up and run it? Remember, earlier I just said that inference is an extraordinary computation problem. How would you do the optimization for each and every one of these models and put together the computing stack necessary to run that supercomputer so that you can run these models in your company? And so we have a great idea. We're going to invent a new way for you to receive and operate software.
Okay.
This software comes basically.
Me parece muy bonito. A ver, ¿cuánto hay que pagar para usar eso? ¿Cuánto hay que pagar?
The Nvidia Inference Microservice, a NIM.
Bueno, primera vez.
And let me explain to you what it is. A NIM. It's a pre-trained model, so it's pretty clever.
Un modelo preentrenado.
Packaged and optimized to run across Nvidia's install base, which is very, very large. What's inside it is incredible. You have all these pre-trained, state-of-the-art open source models. They could be open source, they could be from one of our partners, it could be created by us, like NVIDIA MolMIM. It is packaged up with all of its dependencies. So CUDA, the right version, cuDNN, the right version, TensorRT, LLM, distributing across the multiple GPUs, Triton Inference Server, all completely packaged together. It's optimized, depending on whether you have a single GPU, multi-GPU, or multi-node of GPUs, it's optimized for that. And it's connected up with APIs
tengo
that are
una
simple to use.
GTX 950.
What an AI API is.
Ahora está la 4090 RTX, pero
that you just talk to.
Buah.
And so this is
Eso
a piece of
coge lo
software in the
mío
future
que flipas.
that has a really simple API, and that API is called Human. And these packages, incredible bodies of software, will be optimized and packaged, and we'll put it on a website. And you can download it, you could take it with you, you could run it in any cloud, you could run it in your own data center, you can run in workstations if it fits.
Hombre, ahora la nube y tal es bastante potente. Yo uso un PC en la nube.
Nvidia Inference Microservice, but
Hasta con el móvil podría ponerme a jugar al Elden Ring y a todo. Solo tengo que conectarme a esa nube.
Just imagine, you know, someday there's going to be one of these chatbots, and these chatbots is going to just be in a NIM, and you'll assemble a whole bunch of chatbots, and that's the way software is going to be built someday. How do we build software in the future? It is unlikely that you'll write it from scratch or write a whole bunch of Python code or anything like that. It is very likely that you assemble a team of AIs. There's probably going to be a super AI that you use that takes the mission that you give it and breaks it down into an execution plan. Some of that execution plan could be handed off to another NIM. That NIM would maybe understand SAP. The language of SAP is ABAP. It might understand ServiceNow. and it go retrieve some
Muy pocos
information from
conocen
their
ese lenguaje.
platforms. It might then hand that result to another NIM who goes off and does some calculation on it. Maybe it's an optimization software, a combinatorial optimization algorithm. Maybe it's,
Claro, los de la IA madre que se encarga de repartir las tareas.
Maybe it's pandas to do some numerical analysis on it. And then it comes back with its answer, and it gets combined with everybody else's, and because it's been presented with this is what the right answer should look like, it knows what right answers to produce, and it presents it to you. We can get a report every single day at top of the hour that has something to do with a build plan or some forecast or some customer alert or some bugs database or whatever it happens to be, and we could assemble it using all these NIMs. And because these NIMs have been packaged up and ready to work on your systems, so long as you have NVIDIA GPUs in your data center or in the cloud, this NIMs will work together as a team and do amazing things. And so we decided, this is such a great idea, we're going to go do that. And so NVIDIA has NIMs running all over the company. We have chatbots being created all over the place, and one of the most important chatbots, of course, is a chip designer chatbot. You might be surprised, we care a lot about building chips. And so we want to build chatbots, AI co-pilots, that are co-designers with our engineers. And so this is the way we did it. So we got ourselves a Llama 2, this is a 70B, and it's packaged up in a NIM, and we asked it, what is a CTL? Well, it turns out CTL is an internal program, and it has an internal proprietary language, but it thought the CTL was a combinatorial timing logic, and so it describes, conventional knowledge of CTL, but that's not very useful to us. And so we gave it a whole bunch of new examples. This is no different than onboarding an employee. We say, thanks for that answer, it's completely wrong. And then we present to them, this is what a CTL is, okay? And so this is what a CTL is at NVIDIA. And the CTL, as you can see, CTL stands for Compute Trace Library, which makes sense. We were tracing compute cycles all the time, and it wrote the program.
O sea, que lo han enseñado y ya está escrito el programa. Claro, y la vas entrenando. Pues yo quiero entrenar así ya, tío.
First thing you can do with it is customize it. We have a service called Nemo Microservice that helps you curate the data, preparing the data so that you could teach this.
No se llama Nemo, se llama NIM.
You fine tune them.
Ah, coño, sí que se llama Nemo.
Guardrail it. You can even evaluate the
¿Por
answer,
qué Nemo?
evaluate its performance against other examples. And so that's called the Nemo Microservice. Now, the thing that's emerging here is this. There are three pillars of what we're doing. The first pillar is, of course, inventing the technology for AI models and running AI models and packaging it up for you. The second is to create tools to help you modify it. First is having the AI technology. Second is to help you modify it. And third is infrastructure for you to fine-tune it, and if you like, deploy it. You could deploy it on our infrastructure called DGX Cloud, or you can deploy it on-prem, you can deploy it anywhere you like. Once you develop it, it's yours to take anywhere. And so we are effectively an AI foundry.
Aquí un coche chetado.
We will do for you and the industry on AI what TSMC does for us building chips.
Compras una mierda de ella y te la llevas contigo a todos lados y la ejecutas donde quieras.
They manufacture and we take it with us.
Le das acceso al PC entero y le decimos, venga, vamos a jugar al Helldivers con Saúl. Y dejamos que la IA vaya y haga mierdas en el Helldivers. ¿Te lo imaginas? Todo tío. Jugando como jugador. Le das una cuenta de Steam. Dice, venga, esos son los juegos que tienes. Ay, pero no tengo ninguno. Pues consigue dinero y cómpratelo. Fucking bitch, ¿qué quieres que te lo compre yo? Pago varios millones por ti. Qué guapo, tío.
Knowledge into a new type of database called a vector database. And so you essentially take structured data or unstructured data, you learn its meaning, you encode its meaning, so now this becomes an AI database, and that AI database, in the future, once you create it, you can talk to it. And so let me give you an example of what you could do. So suppose you got a whole bunch of multi-modality data, and one good example of that is PDF. So you take the PDF, you take all of your PDFs, all your favorite, the stuff that is proprietary to you, critical to your company. You can encode it, just as we encoded pixels of a cat, and it becomes the word cat. We can encode all of your PDF, and it turns into vectors that are now stored inside your vector database. It becomes the proprietary information of your company. And once you have that proprietary information, you can chat to it. It's a smart database. And so you just chat with data. And how much more enjoyable is that? For
yo no le habría puesto imagen de gato, tío.
Chat with the bugs database. How many bugs was there last night? Are we making any progress? And then after you're done talking to this bugs database, you need therapy. And so
y tenemos otro chamo para la terapia, ¿no? Claro. Cuando te dicen los errores que ha habido.
You can do it.
Y te dice, tú puedes hacerlo. ¿Qué hijo de puta es, tío? Esto es verdad. Vas, ves los errores de mierda que han salido, luego vas con la IA de psicología.
And the reason for that is because ultimately its job is to go retrieve information as quickly as possible. And you just talk to it. Hey, retrieve me this information. It goes, it brings it back to you. And do you mean this? You go, yeah.
Imagínate ir a esta conferencia, vas, ves la charla y luego ya ves todo lo que se puede hacer en los puestos que tienen afuera. Te tomas algo, pam.
I'm Rachel, your AI care manager.
Mira, ahí está, un ejemplo, sí.
So it's a really short clip, but there were so many videos to show you, I guess, so many other demos to show you, and so I had to cut this one short. But this is Diana. She is a digital human NIM, and you just talked to her, and she's connected, in this case, to Hippocratic AI's large language model for healthcare, and it's truly
amazing.
Médica. She is just super smart about healthcare things. And so after you're done, after my Dwight, my VP of software engineering, talks to the chatbot for bugs database, then you come over here and talk to Diane. And so Diane is completely animated with AI, and she's a digital human.
Okay, vamos a verlo.
There's so many companies that would like to build. They're sitting on gold mines. The enterprise IT industry is sitting on a gold mine. It's a gold mine because
una experta en medicina,
of the way work is done. They have all these amazing tools that have been created over the years, and they're sitting on a lot of data. If they could take that gold mine and turn them into co-pilots, these co-pilots could help us do things. And so just about every IT franchise, IT platform in the world that has valuable tools that people use is sitting on a gold mine for co-pilots, and they would like to build their own co-pilots and their own chatbots. And so we're announcing that NVIDIA AI Foundry is working with some of the world's great companies. SAP generates 87% of the world's global commerce. Basically, the world runs on SAP. We run on SAP. NVIDIA and SAP are building SAP Joule co-pilots using NVIDIA NeMo and DGX Cloud. ServiceNow, they run 85% of the world's Fortune 500 companies run their people and customer service operations on ServiceNow. And they're using NVIDIA AI Foundry to build ServiceNow Assist virtual assistants. Cohesity backs up the world's data. They're sitting on a gold mine of data. Hundreds of exabytes of data, over 10,000 companies. NVIDIA AI Foundry is working with them, helping them build their Gaia generative AI agent. Snowflake is a company that stores the world's digital warehouse in the cloud and serves over 3 billion queries a day for 10,000 enterprise customers. Snowflake is working with NVIDIA AI Foundry to build co-pilots with NVIDIA NeMo and NIMS. NetApp, nearly half of the files in the world are stored on-prem on NetApp. NVIDIA AI Foundry is helping them build chatbots and co-pilots like those vector databases and retrievers with NVIDIA NeMo and NIMS.
Están currando ahora los desarrolladores en todas esas empresas.
Everybody who is building these chatbots and generative AI, when you're ready to run it, you're going to need an AI factory. And nobody is better at building end-to-end systems of very large scale for the enterprise than Dell. And so anybody, any company, every company will need to build AI factories. And it turns out that Michael is here. He's happy to take your order.
A ver, ¿está el tío de Dell ahí? Sí que
Ladies and
está.
gentlemen, Michael Dell.
Joder, cuántos empresarios hay ahí, me cago en su puta
The
madre.
next wave of robotics, the next wave of AI, robotics, physical AI.
Ahí sí que haces contactos si se
So
consigue una
far,
entrada a
all
esto.
of the AI that we've talked about is one computer. Data comes into one computer, lots of the
Ahí está el
world's,
sistema.
if you will,
Robótica,
experience in digital text form.
el Omniverse
AI
y
imitates
la
us
IA.
by reading a lot of the language to predict the next words. It's imitating you by studying all of the patterns and all the other previous examples. Of course, it has to understand context and so on and so forth, but once it understands the context, it's essentially imitating you. We take all of the data, we put it into a system like DGX, we compress it into a large language model, trillions and trillions of parameters become billions and billions, trillions of tokens becomes billions of parameters, these billions of parameters becomes your AI. Well, in order for us to go to the next
En el
wave of
futuro
AI,
cada uno
where
tendrá
the
su
AI
propia IA.
understands the physical world, we're going to need 3 computers.
Así en el móvil.
The first computer
Tu
is still
propia
the
IA.
same
Ya no
computer.
usamos
It's that
una
AI
sola,
computer
que ahora
that
mismo todo el
now
mundo
is
está
gonna
con
be watching
ChatGPT.
video and maybe
Y es solo
doing
una
some data
IA que recibe
generation,
estas
maybe
órdenes
there's a
y
human
se encarga de manejar las respuestas en
examples,
general.
just as we have human examples in text form,
Por
we're
eso a
gonna have
veces
human
tarda un poco en
examples
contestar.
in
Pero si
articulation
cada uno
form,
tuviera la suya,
and the AI is gonna
personal,
watch us, understand what is
experta en la
happening,
persona en sí.
and try to adapt it for themselves into the context.
Así es.
And
Así
because
es.
it can generalize with these foundation models,
Eso
maybe
también es
these
bonito.
robots can also perform in the physical world fairly generally. So I just described in very simple terms essentially what just happened in large language models, except the ChatGPT moment for robotics may be right around the corner. And so we've been building the end-to-end systems for robotics for some time. I'm super, super proud of the work. We have the AI system, DGX. We have the lower system, which is called AGX for autonomous systems, the world's first robotics processor. When we first built this thing, people are, what are you guys building? It's a SoC, it's one chip, it's designed to be very low power, but it's designed for high-speed sensor processing and AI. And so if you want to
Robots con inteligencia artificial. Ya están saliendo. Creo que van a enseñar uno, ¿eh? Van a enseñar un robot de mierda de
we have
esos.
the perfect computer for you. It's called the Jetson. And so the DGX on top for training the AI, the Jetson is the autonomous processor, and in the middle, we need another computer. Whereas large language models have the benefit of you providing your examples and then doing reinforcement learning human feedback. What is the reinforcement learning human feedback of a robot? Well, it's reinforcement learning physical feedback. That's how you align the robot. That's how the robot knows that as it's learning these articulation capabilities and manipulation capabilities, it's going to adapt properly into the laws of physics. And so we need a simulation engine that represents
El
the world
Omniverse,
digitally
que habéis
for the
dicho
robot, so
antes
that
y
the
que lo habéis
robot has a
explicado antes.
gym to go learn how to be
Un
a robot.
gimnasio para aprender
We
a ser un
call
robot.
that
Omniverse.
virtual world Omniverse.
Qué
And the
guapo.
computer that runs Omniverse is called OVX. And OVX, the computer itself, is hosted in the Azure cloud.
Qué bonito,
So
tío.
basically, we built these 3 things, these 3 systems. On top of it, we have algorithms for every single one. Now, I'm going to show you one super example of how AI and Omniverse are going to work together. The example I'm going to show you is kind of insane, but it's going to be very, very close to tomorrow.
Vale.
It's a robotics building. This robotics building is called a warehouse. Inside the robotics building are going to be some autonomous systems. Some of the autonomous systems are going to be called humans, and some of the autonomous systems are going to be called forklifts. And
Qué
these autonomous
bonito.
systems are going to interact with each
Dios.
other, of course, autonomously, and it's going to be overlooked upon by this warehouse to keep everybody out of harm's way. The warehouse is essentially an air traffic controller. And whenever it sees something happening, it will redirect traffic and give new waypoints, just new waypoints to the robots and the people, and they'll know exactly what to do. This warehouse, this building, you can also talk to. Of course you could talk to it. Hey, SAP Center, how are you feeling today? For example. And so you could ask the warehouse the same questions. Basically, the system I just described will have Omniverse Cloud that's hosting the virtual simulation, and AI running on DGX Cloud, and all of this is running in real time. Let's take a look.
Vamos a ver, vamos a ver, vamos a
The
ver.
future of heavy industries starts as a digital twin. The AI agents helping robots, workers, and infrastructure navigate unpredictable events in complex industrial spaces will be built and evaluated first in
Todo Juanilla, chaval, entrenamiento virtual.
This Omniverse digital twin of a 100,000 square foot warehouse is operating as a simulation environment that integrates digital workers, AMRs running the Nvidia Isaac Perceptor stack, centralized activity maps of the entire warehouse from 100 simulated ceiling mount cameras using Nvidia Metropolis, and AMR route planning with Nvidia Cuopt. Software in loop testing of AI agents in this physically accurate simulated environment enables us to evaluate and refine how the system adapts to real-world unpredictability. Here, an incident occurs along this AMR's planned route, blocking its path as it moves to pick up a pallet. Nvidia Metropolis updates and sends a real-time occupancy map to Cuopt, where a new optimal route is calculated. The AMR is enabled to see around corners and improve its mission efficiency.
Oh.
With AI-powered Metropolis Vision Foundation models, operators can even ask questions using natural language. The visual model understands nuanced activity and can offer immediate insights to improve operations. All of the sensor data is created in simulation and passed to the real-time AI, running as NVIDIA Inference Microservices, or NIMs. And when the AI is ready to be deployed in the physical twin, the real warehouse, we connect Metropolis and Isaac NIMs to real sensors with the ability for continuous improvement of both the digital twin and the AI models.
Isn't that incredible?
Sí.
And so, remember, a future facility, warehouse, factory, building will be software defined. And so the software is running. How else would you test the software? So you test the software to building the warehouse, the optimization system in the digital twin. What about all the robots? All of those robots you were seeing just now, they're all running their own autonomous robotic stack. And so the way you integrate software in the future, CI/CD in the future, for robotic systems is with digital twins. We've made Omniverse a lot easier to access. We're going to create basically Omniverse cloud APIs, 4 simple API and a channel, and you can connect your application to it. So this is going to be as wonderfully, beautifully simple in the future that Omniverse is going to be. And with these APIs, you're going to have these magical digital twin capability. We also have turned Omniverse into an AI and integrated it with the ability to chat USD. The language of our language is, human, and Omniverse's language, as it turns out, is universal scene description. And so that language is rather complex, and so we've taught our Omniverse that language. And so you can speak to it in English, and it would directly generate USD. And it would talk back in USD, but converse back to you in English. You could also look for information in this world semantically. Instead of the world being encoded semantically in language, now it's encoded semantically in scenes. And so you could ask it of certain objects or certain conditions and certain scenarios, and it can go and find that scenario for you. It also can collaborate with you in generation. You could design some things in 3D, it could simulate some things in 3D, or you could use AI to generate something in 3D. Let's take a look at how this is all going to work. We have a great partnership with Siemens. Siemens is the world's largest industrial engineering and operations platform. You've seen now so many different companies in the industrial space. Heavy industries is one of the greatest final frontiers of IT. And we finally now have the necessary technology to go and make a real impact. Siemens is building the industrial metaverse. And today we're announcing that Siemens is connecting their crown jewel accelerator to NVIDIA Omniverse. Let's take a look.
Vamos a ver, vamos a ver.
Siemens technologies transform the everyday for everyone. Teamcenter X, our leading product lifecycle management software from the Siemens Accelerator platform, is used every day by our customers to develop and deliver products at scale. Now we are bringing the real and the digital worlds even closer by integrating Nvidia AI and Omniverse technologies into Teamcenter X. Omniverse APIs enable data interoperability and physics-based rendering to industrial-scale design and manufacturing projects. Our customers, HD Hyundai, market leader in sustainable ship manufacturing, builds ammonia and hydrogen-powered ships, often comprising over 7 million discrete parts. With Omniverse APIs, Teamcenter X lets companies like HD Hyundai unify and visualize these massive engineering data sets interactively and integrate generative AI to generate 3D objects or HDRI backgrounds to see their projects in context. The result? An ultra-intuitive, photoreal, physics-based digital twin that eliminates waste and errors, delivering huge savings in cost and time. And we are building this for collaboration, whether across more Siemens accelerator tools like Siemens NX or Star CCM+, or across teams working on their favorite devices in the same scene together. This is just the beginning. Working with Nvidia, we will bring accelerated computing, generative AI, and Omniverse integration across the Siemens accelerator portfolio.
The professional voice actor happens to be a good friend of mine, Roland Busch, who happens to be the CEO of Siemens. Once you get Omniverse connected into your workflow, your ecosystem, from the beginning of your design to engineering, to manufacturing planning, all the way to digital twin operations. Once you connect everything together, it's insane how much productivity you can get. And it's just really, really wonderful. All of a sudden, everybody's operating on the same ground truth. You don't have to exchange data and convert data, make mistakes. Everybody is working on the same ground truth. From the design department to the art department, the architecture department, all the way to the engineering and even the marketing department. Let's take a look at how Nissan has integrated Omniverse into their workflow. And it's all because it's connected by all these wonderful tools and these developers that we're working with. Take a look.
都能使这款车型焕发出独特的魅力。
我喜欢有质感些的灰色。
非常好的选择。
哦。No! No, qué guapo, chaval.
That was not an animation, that was Omniverse. Today we're announcing that Omniverse Cloud streams to the Vision Pro.
¿Por qué la Vision Pro?
It is very, very strange that you walk around virtual doors when I was getting out of that car, and everybody does it. It is really, really quite amazing. Vision Pro connected to Omniverse portals you into Omniverse. And because all of these CAD tools and all these different design tools are now integrated and connected to Omniverse, you can have this type of workflow. Really incredible. Let's talk about robotics. Everything that moves will be robotic. There's no question about that. It's safer, it's more convenient. And one of the largest industries is going to be automotive. We build the robotic stack from top to bottom, as I was mentioned, from the computer system, but in the case of self-driving cars, including the self-driving car application. At the end of this year, or I guess beginning of next year, we will be shipping in Mercedes, and then shortly after that, JLR. And so these autonomous robotic systems are software-defined. They take a lot of work to do, has computer vision, has obviously artificial intelligence, control and planning, all kinds of very complicated technology, and takes years to refine. We're building the entire stack. However, we open up our entire stack for all of the automotive industry. This is just the way we work. The way we work in every single industry, we try to build as much of it as we can so that we understand it, but then we open it up so that everybody can access it. Whether you would like to buy just our computer, which is the world's only full, functional, safe ASIL-D system that can run AI, this functional, safe ASIL-D quality computer, or the operating system on top, or, of course, our data centers, which is in basically every AV company in the world. However you would like to enjoy it, we're delighted by it. Today we're announcing that BYD, the world's largest EV company, is adopting our next generation. It's called Thor. Thor is designed for transformer engines. Thor, our next generation AV computer, will be used by BYD. You probably don't know this fact that we have over 1 million robotics developers. We created Jetson, this robotics computer. We're so proud of it. The amount of software that goes on top of it is insane. But the reason why we can do it at all is because it's 100% CUDA compatible. Everything that we do in our company is in service of our developers. And by us being able to maintain this rich ecosystem and make it compatible with everything that you access from us, we can bring all of that incredible capability to this little tiny computer we call Jetson, a robotics computer. We also today are announcing this incredibly advanced new SDK. We call it Isaac Perceptor. Isaac Perceptor, most of the robots today are pre-programmed. They're either following rails on the ground, digital rails, or they'd be following April tags. But in the future, they're going to have perception. And the reason why you want that is so that you could easily program it. You say, would you like to go from point A to point B, and it will figure out a way to navigate its way there. So by only programming waypoints, the entire route could be adaptive. The entire environment could be reprogrammed, just as I showed you at the very beginning with the warehouse. You can't do that with pre-programmed AGVs. If those boxes fall down, they just all gum up and they just wait there for somebody to come clear it. And so now, with the Isaac Perceptor, we have incredible state-of-the-art vision odometry, 3D reconstruction, and in addition to 3D reconstruction, depth perception. The reason for that is so that you can have two modalities to keep an eye on what's happening in the world. Isaac Perceptor. The most used robot today is a manipulator, manufacturing arms, and they are also pre-programmed. The computer vision algorithms, the AI algorithms, the control and path planning algorithms that are geometry aware, incredibly computationally intensive. We have made these CUDA accelerated. So we have the world's first CUDA accelerated motion planner that is geometry aware. You put something in front of it, it comes up with a new plan and articulates around it. It has excellent perception for pose estimation of a 3D object. Not its pose in 2D, but its pose in 3D. So it has to imagine what's around and how best to grab it. So the foundation pose, the grip foundation, and the articulation algorithms are now available. We call it Isaac Manipulator, and they also just run on NVIDIA's computers. We are starting to do some really great work in the next generation of robotics. The next generation of robotics will likely be a humanoid robotics. We now have the necessary technology, and as I was describing earlier, the necessary technology to imagine generalized human robotics. In a way, human robotics is likely easier, and the reason for that is because we have a lot more imitation training data that we can provide the robots, because we are constructed in a very similar way. It is very likely that the humanoid robotics will be much more useful in our world because we created the world to be something that we can interoperate in and work well in. And the way that we set up our workstations and manufacturing and logistics, they were designed for humans. They were designed for people. And so these humanoid robotics will likely be much more productive to deploy. While we're creating, just like we're doing with the others, the entire stack. Starting from the top, a foundation model that learns from watching video, human examples. It could be in video form, it could be in virtual reality form. We then created a gym for it called Isaac Reinforcement Learning Gym, which allows the humanoid robot to learn how to adapt to the physical world. And then an incredible computer, the same computer that's going to go into a robotic car, this computer will run inside a humanoid robot called Thor. It's designed for transformer engines. We combined several of these into one video. This is something that you're going to really love. Take a look.
Veamos a los robots actuando como humanos.
It's not enough for humans to imagine. We have to invent and explore and push beyond what's been done.
A fair amount of detail.
We create smarter and faster. We push it to fail so it can learn. We teach it, then help it teach itself. Broaden its understanding to take on new challenges with absolute precision and succeed. We make it perceive and move and even reason so it can share our world with us. This is where inspiration leads us. The next frontier. This is Nvidia Project Groot. A general-purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot, and Omniverse Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation. With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world. The Groot model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks. And emulate human movement just by observing us. This is made possible with Nvidia's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots. Connecting Groot to a large language model even allows it to generate motions by following natural language instructions.
Hi, GL1. Can you give me a high five?
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
All this incredible intelligence is powered by the new Jetson Thor robotics chips, designed for Groot, built for the future. With Isaac Lab, Osmo, and Groot, we're providing the building blocks for the next generation of AI-powered robotics.
Sí.
About the same size.
Qué bonito, tío.
The soul of Nvidia. The intersection of computer graphics, physics, artificial intelligence. It all came to bear at this moment. The name of that project, General Robotics 003. I know, super good. Super good. Well, I think we have some special guests. Do we? Hey guys. So I understand you guys are powered by Jetson. They're powered by Jetsons. Little Jetson robotics computers inside. They learn to walk in Isaac Sim. Ladies and gentlemen, this is orange, and this is the famous green. They are the BDX robots of Disney. Amazing Disney research. Come on, you guys, let's wrap up. Let's go. 5 things. Where are you going? I sit right here. Don't be afraid. Come here, Green. Hurry up. What are you saying? No, it's not time to eat. It's not time to eat. I'll give you a snack in a moment. Let me finish up real quick. Come on, Green, hurry up. Stop wasting time. 5 things. 5 things. First, a new industrial revolution. Every data center should be accelerated. $1 trillion worth of installed data centers will become modernized over the next several years. Second, because of the computational capability we brought to bear, a new way of doing software has emerged. Generative AI, which is going to create new infrastructure dedicated to doing one thing and one thing only. Not for multi-user data centers, but AI generators. These AI generation will create incredibly valuable software. A new industrial revolution. Second, the computer of this revolution, the computer of this generation, generative AI, trillion parameters, Blackwell. Insane amounts of computing. Third, I'm trying to concentrate. Good job. Third, new computer creates new types of software. New type of software should be distributed in a new way so that it can, on the one hand, be an endpoint in the cloud and easy to use, but still allow you to take it with you because it is your intelligence. Your intelligence should be packaged up in a way that allows you to take it with you. We call them NIMs. And third, these NIMs are going to help you create a new type of application for the future. Not one that you wrote completely from scratch, but you're going to integrate them like teams. Create these applications. We have a fantastic capability between NIMs, the AI technology, the tools, NeMo, and the infrastructure DGX Cloud in our AI Foundry to help you create proprietary applications, proprietary chatbots.
Sí, lo más difícil no es crearlo, es integrarlo todo. Y parece que no han conseguido, tía.
And these robotic systems, whether they are humanoid, AMRs, self-driving cars, forklifts, manipulating arms, they will all need one thing. Giant stadiums, warehouses, factories. There can be factories that are robotic, orchestrating factories, manufacturing lines that are robotics, building cars that are robotics. These systems all need one thing. They need a platform, a digital platform, a digital twin platform, and we call that Omniverse, the operating system of the robotics world. These are the 5 things that we talked about today. What does NVIDIA look like? What does NVIDIA look like? When we talk about GPUs, there's a very different image that I have when people ask me about GPUs. First, I see a bunch of software stacks and things like that. And second, I see this. This is what we announced to you today. This is Blackwell. This is the platform. Amazing processors, NVLink switches, networking systems, and the system design is a miracle. This is Blackwell, and this to me is what a GPU looks like in my mind. Listen, orange, green, I think we have one more treat for everybody. What do you think? Should we? Okay, we have one more thing to show you. Roll it. Thank you. Have a great GTC. Thank you all for coming. Thank you.
Muy bonito. Sí, señor. Damas y caballeros, me voy a ir ya a comida y tal. Vamos a dejar el directo aquí. Gracias por acompañarme, ¿vale? Si tenéis algunas dudas o lo que sea, dejadlas en los comentarios. Voy a dejar el enlace del vídeo en la descripción. De hecho, voy a hacerlo ya. Enlace. ¿Vale? Para que lo veáis, si le queréis echar un vistazo o lo que sea. Y nada, que más tarde le vamos a dar a seguir con el reto de las Tepoch y tal. Vamos a pasárnoslo, que nos queda poquito. Yo creo que el 27 o así lo tenemos y vamos poco a poco con buena letra y despacio. Gracias por acompañarme, los que me hayáis acompañado. Y nos vemos más tarde. Habrá más reacciones así. Darle like, suscribiros si queréis ver más. Nunca lo he dicho. Pues lo diré esta vez por primera vez. Y con suerte en un futuro no muy lejano espero poder presenciar esto en directo y haceros ya un vlog más más intenso, ¿no? Por así decirlo, más... Un saludo.